right triangle is going to be the region on YZ plane. That with me? Still two ways you can understand that. One way you can understand is this solid region is built upon this solid, built upon this region on YZ plane. The other thing you can understand is if you squeeze this whole solid onto YZ plane, you're going to get this triangle right here. Okay? Now I need two functions for x. What is the lower function?
0.
Lower function is still 0. The upper function is coming from the equation define the plane. But I need a function to solve for x. So I need an x is equal to something. So I need to solve for this equation with respect to x. So 5x is equal to minus something plus 25. So I divide everything by 5. What I have? Minus 5y minus z plus 5. And then I want to identify this region, our region on YZ plane, as a y simple region. So if it is y simple region, I need two numbers for z, two functions for y. And two numbers for z is pretty simple here. So it's going to be from 0 to 5. Two functions for y. The lower function is pretty clear here. It's still 0. All right? The upper function is going to be coming from this trace equation. All right? And I need a z is equal to something of a y. All right? Oh, sorry, I need a y is equal to something of a z. This is the y simple region. So y is equal to minus z divided by 5 plus 5. What is it? Plus 1. This is coming from solving the equation with respect to z. So then this is z minus 5 to z minus y minus z plus 5, same integrating function dx dy dz. As long as we're on the x simple identification in the very beginning, so in this is going to be x simple in the space, y simple on the plane, right? I can also rewrite this as x simple in the space, but z simple on the plane. All right? We can also do z simple on the plane. So indeed, I want a dx, dz, dy intervening order. Okay? So keep up with me. So if I want to identify this as a z simple region, I don't change anything for the interior, right? I'm only identifying this R region on YZ plane. I need two numbers for y and two functions for z. So what are the two numbers? 0 and 1, right? And z is coming from 0 to the function coming from this trace equation again. But I need a z is equal to something of a y, right? So I need to solve for z in this equation. So z is, in this case, minus 5y plus 5, right? 0 minus 5y minus z plus 5, 1. Okay, that's the integrating function. Okay, so we have, let's recall it again. We have z simple in the space, x simple in the plane. We also have z simple in the space, y simple on the plane. Here we have x simple in the space, y simple on the plane, and x simple in the space, z simple on the plane. So 1, 2, 3, 4. We have 2 more left. So I want to write down all the possible combinations. So this is an extremely nice practice for you to get used to how to identify the region. And so this is pretty much the easiest practice we can find. That will practice your double integral skill as well as triple integral skill. So as long as we have done 4 different identifications, you pretty much already saw the pattern here, right? You already saw the pattern here. Instead of having all these identifications, we can simply look at this equation to define the upper surface. And it's a matter of solving for different variables as the upper function over there, all right? It's just a matter of solving the functions over there. So let's quickly go through dy, dx, dz, and three functions here. So dy, I needed to look at that defining function for the plane and solve for y, all right? I need to solve for y, so it's going to be from a 0. So how to solve for y? It's minus 1 over 5x minus 1 over 5z plus 1. This is the upper function for y. And the two numbers for z is pretty clear from the pictures, from 0 to 5, all right? Z is from 0 to 5. And x is coming from solving this equation, all right? It's coming from this equation. It's coming from 0 to minus 5x plus 5, right?
You guys put 0 to 5?
Yeah,
Which one?
should be.
Here?
For the first one.
For first one? First one, I always need the two numbers.
And how would you pick them?
So they are coming from, on the z direction, from 0 to 5, all right? And then the upper function is coming from solving this line equation, right? So this is straight line, I have an equation right here. I need to solve for x right here, right? So solving for x is equal to minus z plus 5, okay?
Yeah,
So let's
yeah.
quickly write down.
Shouldn't it be there? You had negative 5x. Shouldn't it be z?
Oh,
Yeah.
sorry,
Yeah.
yeah, this is supposed to be minus z.
There's no
Yeah,
5 on
thank
it.
you.
It just used to be negative z.
There's no 5 with the z.
Am I making any mistake?
Just
We
no
use
5.
the other one, so it's negative z plus 5.
Oh, yeah, it should be negative z, because you're still, because you're dividing by 5, so it'd be.
Oh, yeah, exactly. So I'm solving, okay, so this is an arithmetic error. So I'm solving for z. So I'm having 5z is equal to minus 5x plus 25. Dividing both by 5. Yes, I don't have any 5 anymore. Thank you. So it's going to be minus z plus 5. Thank you. So that's the equation to define the upper function with respect to x. And then we can quickly write down the very last combination. So y is still coming from 0 to minus 1 over 5x minus 1 over 5z plus 1. Intervening function is still 1 dy dx dz.
dz here.
I want a dz dx. So dz dx, I need the two numbers for x, which are 0 and 5, and two functions for
Negative
z,
x
so
plus
they are
5.
0 and minus x plus 5. Okay, so now we have all 6 different combinations for the same solid region as the intermediate region of this triple integral. Okay. Okay, so remember what we did when we introduced the triple integral. We began from the easiest case, the cube case. Right? For the cube case, x is bounded by two numbers, y is bounded by two numbers, z is bounded by two numbers. So you can switch the intervening order from one to the other out of the 6. Right? You can switch the order as pleased as you will. And as long as you keep the numbers correspondingly, you're good. For general region, for this kind of regions, we can identify the same solid region as x simple, y simple, and z simple. And we can switch between this one of the 6 to the other. But when we do that, it's going to be more complicated than the cube case. We have to bring all the functions into consideration. Okay, so we have to bring all the functions into consideration. But bottom line is we can interchange all the 6 different combinations. Okay, so if I give you the region looking like this, okay, if I give you a region looking like this, and then I already give you the intermediate order, then you need to identify this correspondingly. For instance, this guy is the y simple as the space and x simple on xy, xz plane. And then you need to come up with all these numbers and functions as the boundary of the integrals. Now with me? So as long as I give you one intervening order, you're supposed to identify the region in this order and then find all the required information to define this triple integral. Okay? So we can identify this as any one of the 6 different types. Questions? Now, as I promised you, I want to apply this triple integral to find one thing. So I want to find the volume of a ball. radius capital R. Let's say just center at 0, center at the origin. Okay. So these kind of problems really give you the power of calculus. Okay, without calculus, it's pretty hard to actually precisely compute the volume is. But from geometry, you probably already knew the formula. So what is the volume of a ball?
4/3 cube.
So the volume of a ball is indeed equal to 4 divided by 3 pi r cubed. So that's the volume. Okay. But today we're going to actually verify why this is true. Am I making any mistake? I think that is the correct formula. Okay, so first of all, we already had that formula over there in order to compute the volume of a solid region in R3. No brainer, I want to write down a triple integral with respect to this region D, identified as the solid ball, integrating with respect to 1. Right? So that is going to be my volume. Yes? Now I want to apply my triple integral evaluation skills. In other words, in order to evaluate the triple integral, the key thing is to identify the region as either z simple region, x simple region, or y simple region. Which kind of type is this solid ball? It is a z simple region. It is a z simple region because you have a upper surface as the upper sphere, all right? And the lower surface as the lower sphere. And the region on xy plane is this disk, am I right? Are you with me? So I want you to immediately identify what this region is. Still, two things you can understand why this is the region on the xy plane. My favorite one is you can squeeze the ball back onto the xy plane, and you're going to get this solid region on the xy plane. In other words, this whole solid region is built upon this disk right over here. Okay? Either you want to use squeeze or you want to use the extension. It's up to you. In fact, this region not only is a z simple region, it is also x and y simple region. All right? So I want you to understand it is indeed an x and a y simple region. If it is an x simple region, I need a sub-region on yz plane where I will squeeze everything back onto. And that region is exactly disk right over here. All right? So this is a disk with radius r, centered at the origin, sitting on yz plane. So if I want to identify it's an x simple region, it is squeezed back onto yz plane. I'm getting this disk. All right? I have upper function as this half sphere and a lower function as the other half square on the back of the board. All right? Yeah. Am I explaining you this three-dimensional space? So in a three-dimensional space, if you use this blackboard cut into two pieces, so x is coming out, so you have an upper function right here and lower function on the other side of the board. All right? So if I want to identify it as a y simple region, I can do the similar thing. I squeeze everything back onto a z plane. I'm getting this disk. All right? I'm getting this disk, and you have an upper surface to this side of the sphere and lower surface to the other side of the sphere. So this is also a region where you can identify in all the 6 different integrating orders. Okay? So choose your favorite one. Probably want to go dz, right? dz is our general geometric understanding. So we want to have an upper and a lower in the usual sense. So dz, and then I need a lower function and an upper function. And now we're pretty smooth about identifying these functions. It is a matter of solving equations. Over there, I have the equation of the plane. Here, I have to solve the equation for the sphere. All right? So the sphere has the equation x squared plus y squared plus z squared is equal to r squared. Which means right in here, I need a lower function, which is the solution of the z, and the upper function is another solution of the z. And then naturally, I have z squared is equal to r squared minus x squared minus y squared. So solving for the negative z, this is exactly defining the lower half sphere. All right? So this lower half sphere has the equation z is equal to minus square root of r squared minus x squared minus y squared. All right? The upper sphere is going to be z is equal to plus r squared minus x squared minus z squared. So I have minus r squared minus x squared minus y squared, and upper is r squared minus x squared minus y squared 1. And then the outside can be dx, dy, or dy, dx, doesn't really matter. But I have to identify it after I eliminate the interior integral. All right? That with me? So I identify this region as the z simple region first. Okay? And then let's see what happens. So if I eliminate the interior integral, I'm going to get double integral r, and I have a function z, evaluating from z is equal to minus r squared minus x squared minus y squared, and z is equal to plus r squared minus s squared minus y squared, then dx dy or dy dx, depending on how I can identify the following. So this is going to be r. Difference of these two is going to be 2 square root of r squared minus x squared minus y squared dy dx. So we need our skill for evaluating double integral. This R is a disk sitting on xy plane, and we discussed this before. For disk on xy plane, we can indeed identify it as x simple. We can also identify it as y simple. I want to quickly write down what it is. If you do not feel very comfortable about this disk sitting on xy plane, you can indeed pull it out and single this region on xy plane as something on the xy plane. So this is indeed what you have on the xy plane. So if you're not used to looking at that disk in a 3-dimensional space, you just simply